Hi, I'm Jimmy Scott.
And I'm Hannah Rild, and our presentation is called Dragon's Breath.
First, before you start any experiment, make sure you have your safety equipment on, your goggles and your gloves. To start this experiment, you're going to need 10 materials. Matches, a 250 milliliter beaker, a 10 milliliter graduated cylinder, and a candle taped to a measuring stick.
You also need a spray bottle, ethanol, lithium chloride, potassium chloride, copper chloride, and water. First, you're going to take the 7.5 milliliters of water, 1.5 grams of lithium, potassium, or copper chloride, and 50 milliliters of ethanol.
Add all those measured substances into your 250 milliliter beaker and mix thoroughly.
Pour the mixture into a spray bottle and prime it a couple times by spraying.
Next, light your candle away from your body, preferably in the fume hood.
And finally, spray the mixture into the flame and observe.
In result of the lithium chloride solution being sprayed through the flame, it produces a red fireball.
Next, we're going to test potassium chloride. And as you can see, potassium chloride creates a purple fireball.
Next is the copper chloride, and when that's sprayed through the solution, you get a nice blue-green color.
The flame is created because ethanol is a very flammable solution.
And the fireballs change color because of a certain iconic compound like lithium, copper, or potassium chloride mixed into the solution.
The reason for the big flame given off is because of the combustion theory.
And the equation for the combustion theory is a compound like lithium, potassium, or copper chloride plus O2 yields CO2 plus H2O.
In this experiment, ethanol and oxygen were the reactants.
And the other compound, again, potassium, copper, or lithium chloride, are mixed with the ethanol, and they are the chemicals that have a chemical makeup to make the color change.
The color changes depending on the energy that's released in the combustion of the elements.
And according to K. Nassau in 1983, the larger the energy output, meaning the faster the wavelength and the higher the frequency, the brighter the flame will burn. And this principle is also responsible for the different color changes that we see here.
So red colors have longer wavelengths and lower frequencies.
Whereas purple and blue colors have a shorter wavelength but higher frequencies.
There are at least 4 real-world applications that also follow the combustion theory principle, and these are road flares, fireworks, neon lights, and car engines.
Road flares, neon lights, fireworks all use the same principle, but fireworks and neon lights use different elements and energy sources to produce their different colors.
Like stated before, different elements burn different colors because of their wavelengths and frequencies.
They burn from an energy source such as fire, like road flares and fireworks, or they could be from an energy source like electricity, as neon lights are.
According to R. Gandia in 2000, a car engine uses the same principle as what we just showed you with the combustion theory, except for it's the car's fuel coming into contact with the engine instead of our solution coming into contact with the flame.
And thank you. I hope you enjoyed our presentation.